nothing to tell. It's just some guy I work with.
Come on. You're going out with the guy. There's got to be something wrong with him.
So does he have a hump and a hairpiece?
Wait, does he eat chalk?
Hi guys, Char lang yun. So, today we're going to be reporting about data movement and data pressing. So, the first reporters are Shane Santiago and Odessa Rontale.
Good morning, everybody. I'm Olivia Shane Santiago.
And I'm Adelaine Rontale.
And today we're going to talk about data movement. So the first thing that we're going to talk about is the I/O devices or the input and output devices. So alam naman natin kung ano yung mga input and output devices, pero meron na examples dito. The first one is the monitor, tapos yung keyboard, yung mouse, tapos yung mga ports, tapos printer, at marami pang iba. Next.
Let us define first movement. Movement is an act of moving something to a particular direction, address, or location. So movement, computer processes, manipulate, and send data according to the instructions from a user. So itong mga instructions na to is i-discuss namin later, and also each computer has input and output interfaces to enable you to connect input or output devices, which is i-discuss din namin in our presentation. Next.
So serial port. So a serial port is either an input or output port that supports serial communication. So ito, as you can see here, yung nasa taas na picture, yan yung nasa dulo ng VGA cord. Tapos yung pagkokonekta niya, either sa TV or sa laptop, yun yung tinatawag na serial port. Tapos sabi dito, it supports serial communication. Ano nga ba yung serial communication? So serial communication is the transmission of data one bit at a time. The data transmitted in a serial communication can be sent using one of the two methods. The first one is yung synchronous data transmission, and then the second one is yung asynchronous data transmission. So kapag sinabi natin na synchronous data transmission, a clock signal regulates the flow of data over a cable or wire. This transmission method is used when large amounts of data must be transferred in a short period of time. So yung kailangan mong tandaan pag sinabing synchronous data transmission is ginagamit siya for large amounts of data. Tapos sa asynchronous data transmission naman, it uses a single information bit referred to as the start bit to tell the computer when to start transmitting data and a stop bit to tell it when to stop. This method is used when you are transferring smaller amounts of data. So ngayon naman, yung asynchronous naman, ginagamit siya kapag smaller amounts of data. Yung sa synchronous kanina, larger amounts of data. Tapos, merong tinatawag na start bit. So, it indicates where the data starts. Tapos, stop bit, it indicates, syempre, where the data stops. Tapos, meron din tayong parity bit. It is used to check if the data is error-free. So, makikita niyo dito sa picture sa baba. Bago mag-start, syempre, nasa 0. Tapos, kapag start bit, syempre, magwa-1 siya. Tapos, magta-transfer yan ng data dito. Tapos, bago siya dumating sa stop bit, meron munang parity bit. Yung parity bit, dyan niya i-check kung tama ba lahat ng data na transmit. Tapos, kapag tama, magpo-proceed na yan sa stop bit. Next.
Parallel port. So, parallel port is a type of interface found on computers used for connecting, or output port that supports parallel communication. So, ano nga ba yung parallel communication? So, parallel communication can transmit and process data one byte at a time. Next. So, in addition, parallel communication is the process of transmitting and processing data 1 byte or 8 bits at a time. So makikita nyo dito sa picture namin na ito yung 8 bits, and along dito sa 8 bits na to ay carry sila ng signal. Ayan. Meron yan isa-isa. Next.
So the next one is USB ports. USB, Universal Serial Bus, is an external bus technology for high-speed connection of peripheral devices. The USB specification was published in 1996 through the joint work of Compaq, Dell, IBM, Intel, Microsoft, NEC, and Nortel. So, yung mga USB port, syempre makikita natin yan sa laptop. Typically, kada laptop meron siyang 3 USB ports, pero yung iba naman, 2 lang. Tapos, over here naman sa picture natin sa right side, kapag marami yung USB ports, ang tawag dyan is USB hub.
Bandwidth, the capacity of a network line to carry information. So, bandwidth is also calculated in Mbps or also known as megabytes per second. So, madalas na pagkakamali ng mga tao na ang bandwidth is the internet speed. Pero, it is actually the volume of information and data that can be sent over a connection in a certain amount of time. Next.
Monitor. So, the monitor is the most common type of output device. It may look like a simple television or flat screen, but it is not. The monitor enables the human eye to interact with the computer. Without a monitor, the computer's output capabilities would be very limited. The monitor enables the computer to translate computer data into text and graphics and display them. So, alam naman natin yung gamit ng monitor. Self-explanatory na yan. And then the next one naman is the keyboard and mouse. The keyboard is the most common type of input device. The keyboard takes information in the form of letters and numbers. The letters and numbers are translated into instructions that the computer must perform. The computer translates literally what is entered, so any typing mistakes will result in an error. So, ayun naman, yun yung mismong gamit ng keyboard natin, di ba? Yung tinatype natin dito, nakikita natin yung naiintindihan lang ng normal na tao. At hindi naman lahat ng tao naiintindihan yung nasa loob ng computer, right? So, yung keyboard, very important siya kasi nagkakaroon ng communication between the user and the computer. At ganun din naman yung mouse. At syempre, yung mouse, basically, ginagamit siya para mag-take control yung user. Next.
So next, digital subscriber line or DSL. So it's still used and is relatively inexpensive technology offered through the local telephone company. So DSL has been successful in the residential small office internet access market because of its potential. But also DSL is distance sensitive, meaning you will have a good connection if mas malapit ka doon sa central office. While if mas malayo ka naman, pwedeng mag-decrease yung signal mo and magkaroon ka ng slow connection. So next.
DSL, a digital signaling method used to transmit data over regular phone lines at speed up to 6 Mbps. DSL uses asynchronous transfer mode to pass data in fixed size cells. So that's it for the DSL, for the input and output devices. So moving on to data movement instructions. It moves data from one place called the source operand to another place called the destination operand. Data movement instructions can be grouped into loads, stores, moves, and immediate loads. So yung pagkukunan mo ng data, ang tawag doon is source operand. Tapos yung pagdadalhan mo naman ng data, ang tawag doon is destination operand. So, data movement instructions. So, yung load instructions move data from memory to registers. Tapos, yung store instructions move data from registers to memory. And then, yung move instructions, it moves data from one register to another register. Tapos, yung immediate load instructions, it moves constants including addresses papunta sa registers. So, exchange instruction. So it is used to exchange the data from two locations. So as you can see here, ito yung instruction, which is yung exchange instruction. Tapos meron ditong dalawang register. Same silang 16 bits. So pwede silang mag-exchange ng dalawang location. Ito pwede mapunta dito, tapos yung ito pwede rin mapunta dito sa kabila naman. So kailangan na parehas ng register. For example, ito, parehas lang 16-bit. Kung kunwari 16-bit tong isa tapos yung isa 8-bit, hindi pwede magkakaroon ng error, hindi matatransfer yung data. And then moving on, move instruction. It transfers word or byte from register to register, memory to register, register to memory, or with immediate data. The data is not really being transferred. It is just being copied from the source to the destination. the source and destination needs to be of the same size. So, ayun yung sinasabi ko kanina, na kapag 8-bit yung isang register, kailangan yung isa din is 8-bit. Tapos kapag 16 naman, kailangan yung isa 16-bit din. Move instructions does not affect any flag. So, ito, magbigay tayo ng example. Our example here is an immediate addressing mode. So, yung move, ito yon yung instruction mo. Register mo, internal register mo is BX, and then ito yung 16-bit data mo, yung 00F2. Tapos, yung register mo, meron niyang two parts. The first one is the BH, tapos yung second one, BL. Yung BH, yun yung higher order register, and then yung BL mo, yun yung lower order register. So, since ito, ipapaghiwalay mo yan dito sa higher order, dun mapupunta yung 00, tapos yung lower order, dun naman magpupunta yung F2. And then the next one is the push and pop instruction. Push instruction it is used to store or add data into the stack, and then the push instruction it is used to remove data from the stack. So let me give an example for you to better understand what push and pop is. So as you can see here, ito yung mga susundin nating instructions. Tapos ito naman, ito yung stack natin. So sabi dito, push 3. Pag sinabing push, 'di ba, sabi kanina, yun yung mag-a-add ka. Tapos pop, magtatanggal. So push 3, ito yung number 3. So kukunin natin yung number 3 ngayon. Ilalagay natin yan dito sa location 0. So yung nasa top ngayon ng stack mo is 0. So kukunin mo tong 0, ilalagay mo sa top. Kasi siya yung nasa top. And then, sabi dito, pop. So, tatanggalin mo yung 3. Ito yung tatanggalin mo kasi yan yung pinush mo kanina, diba? Kung ano yung pinush mo, yun yung tatanggalin mo. So, tanggalin mo yung 3. Ngayon, ano nang nasa top? Wala. So, ang ilalagay mo dyan is -1. And then, the next instruction is push 14. Kunin mo tong 14, place it here. And then, push 31. You place it here. And then, push 5. Oh, I'm sorry, I forgot to add the top. So, pag push mo ng 14, 0 yung nasa top. And then, pag push mo ng 31, 1 yung nasa top. And then, pag push mo ng 5, I'm sorry, that's not 5. 5. Pag push mo ng 5, yan, pag push mo ng 5, ang nasa top is yung 2. So, kunin mo tong 2, tapos place mo dyan. Tapos sabi, pop. 6, diba? Pop. So, kung ano yung nasa taas ng stack, yun yung tatanggalin mo. So, since 5 yung nasa taas ng stack, tatanggalin mo yung 5 ngayon. Ang nasa top na ulit nung stack mo is the 1. So, yung 1, lalagay mo dito. Tapos, pop ulit. So, yung next ulit na nasa top ng stack is 31. So, tatanggalin mo yung 31. Tapos, ang natira ngayon is 0. So, kukunin mo tong 0, lalagay mo dyan sa top. So, basically, yan lang yung push and pop na method. And then the next one is the in and out. So, I'll stop sharing my screen so Odessa can show you guys her example.
Next is in and out. So in, used to read a byte or word from the provided port to the accumulator. Then out, used to send out a byte or word from the accumulator from the provided port. So to understand it more, I will show you examples. So here are the examples. So I have here the instruction wherein it's in, then I have destination, and this is the source. So to explain this instruction, the data from the input port or the OF8H is copied to the accumulator register. So the data will be stored in the accumulator register. So there are 256 input and output ports. So this is just one of them. Then next is the out instruction. So I have here again the out instruction. Then I have here again the destination and the source. So from the accumulator register, wherein the data is stored here, the data will be stored in the output port, in the O and the 047H. So that's the example of in and out. So next. Instruction to transfer the address. LEA, used to load the address of the operand into the provided register. LDS, used to load the DS register and other provided register from the memory. So this DS register is also called the data segment register. LES, used to load ES register and other provided register. So ES stands for extra segment register. So next.
So moving on to instructions to transfer flag registers. So LAHF flag is used to load AH with low byte of flag register. SAHF is used to store AH register to low byte of the flag register. And then pushF, it is used to copy the flag register at the top of the stack. And then popF, it is used to copy a word at the top of the stack to the flag register. Next.
So next is the arithmetic instruction. So instructions which perform basic arithmetic operations such as addition, subtraction, multiplication, and division. So here are the operations. So these are the instructions to perform addition. So I have here the ADD. It is used to add the contents of the destination with the source. And ADC used to add with carry. So again, this is the destination and source, and the instruction will be placed before the destination. So here's the example. I have here ADD and the destination and the source. So this is an 8-bit immediate data. So, and this is the accumulator register, which is also 8-bit. So you will just add this 2, and the sum will be stored again in the accumulator register, which is the destination. So same goes to ADC. I have here AX and BX register. So both of these 2 registers will be added along with the carry flag, and the contents will be stored in the accumulator. So parehas lang sila. Ang pinagkaiba lang nila is sa add, wala tayong carry. Then sa ADC, meron tayong carry. So next. Next is the instructions to perform subtraction. So I have here SUB, used to subtract the byte from the byte or from word. SBB, used to perform subtract with borrow. DEC, used to decrement the provided byte word by 1. CMP, used to compare 2 provided byte or word. So here are the examples. So I have here SUB and the destination and the source. So all we have to do is subtract OFH in the lower order register of the accumulator, which is the AL. And the result will be stored in the AL because it is the destination. So here, we have here SBB. So I have here 2 operands with borrow flag. So all we have to do is subtract each other, and then together with the borrow flag, and then the result will be stored in the AX, wherein it is the destination. Then I have here DEC AL. So AL will be decremented by 1. So next. Okay, in you comparing 2 contents, I have here CMP, AX, and BX. So to assume this is the value of 2. So I have here MOV AX 500. Move the 500 in AX. So AX would be 500. Then here I have here MOV BX and 200. So we will just copy the data and this will be 200. So I have here 500 and 200. So we will just compare it. So it's obvious that 500, the AX is greater than BX. So we can see here the destination is greater than the source. And its zero flag is 0 and carry flag is 0. So if you, kapag nilagay nyo to sa program, kapag in-emulate nyo siya, makikita nyo dun sa baba na merong flag na nakasulat. Kapag pinindot nyo yun, lalabas dun yung mga flags along sa mga value ng mga ganito. Like zero flag and carry flag. So next.
So the next one is instructions to perform multiplication. So MUL, it is used to multiply unsigned byte by byte or word by word. So yung MUL or mule, para siya sa unsigned. Tapos yung IMUL naman, it is used to multiply signed byte by byte or word by word. So IMUL, signed, tapos yung mule naman, unsigned. Next. Instructions to perform division. Div or div, it is used to divide the unsigned word by byte or unsigned double word by word. So unsigned parehas, yung div. Tapos kapag naman idiv, it is used to divide the signed word by byte or signed double word by word. So tandaan nyo na kapag div lang, unsigned siya. Tapos kapag idiv, signed siya. Tapos CWD, it is used to fill the upper word of the double word with the signed bit of the lower word. Next.
Next is bit manipulation instructions. So these are used to perform operations where data bits are involved. Operations like logical shift and others. So instructions to perform logical operations. I have here not, or, and, XOR, and then test used to add operands to update flags without affecting the operands. So familiar naman tayo dito sa mga logical operations na to kasi na-discuss na natin to last year. So ito yung example ko. So we have destination and source again na gagawin nating pagbabasihan. And first, dito muna tayo sa AND. So I have here AND, BL, and AL. So these are 8-bit. So assume this is the value. So I have here sa BL, meron tayong 1000, 0110. And sa AL naman, meron tayong 1100, 1010. So since AND, i-multiply natin tong both operands. So 0 times 0 is 0, 1 times 1 is 1, 1 times 0 is 0, 0 times 1 is 0, 0 times 0, 0, 0 times 0, 0, 0 times 1 is 0, 1 times 1 is 1. Now, this result will be stored in the destination, which is the BL. So, ang next naman natin is sa OR. So, same 8-bit. So, dito naman, i-add natin sila parehas. So, 0 plus 0 is 0, 1 plus 1 is 1, 1 plus 0 is 0, 0 plus 1 is 1, 0 plus 0 is 0, 0 plus 0, 0, 0 plus 1, 1, and 1 plus 1 is 1. So, yung same lang siya na nakuha natin yung sagot is i-store din natin sa destination. So, next is yung XOR. XOR, AX, and 0098H. So, this is a 16-bit. So, suppose this is the bit. So, alam naman natin na kapag XOR, kapag hindi same hindi sila same ng value, ang sagot is 1. Kapag same naman sila, ang sagot is 0. So, ito, 1, 0 is equals to 1, 0 plus 0 is 0, 0 and 1, 1, 1 and 1, since pareha sila, magiging 0. Same, magiging 0. Same ulit, magiging 0. Hindi sila parehas, so 1. Hindi sila parehas, 1. Same, magiging 0. Same, magiging 0. Hindi parehas, magiging 1. Hindi sila parehas, magiging 1. Hindi sila parehas, 1. Hindi sila parehas, 1. And ito, same sila, so 0, 0. So, yun lang. Ganun lang din. And may store ulit siya dito sa ating destination. So, lastly, yung sa NOT. So, I have here NOT AX, which is a 18-bit register. So, suppose this is the bit. So, ito, ano lang to, iko-complement lang. So, bale, ang 0 is magiging 1, and ang 1 is magiging 0. So, ayan, performance complement to get the result. So, ito na yung result. And that's all. Next is string instructions. A group of bytes, words, and their memory is always allocated in sequential order. So, REP, used to repeat the given instruction till counter register or count register is not equal to 0. REPE or REPEZ, used to repeat the given instruction until the count register is 0 or 0 flag is equal to 1.
So next, MOVS or MOVSB or the MOVSW. It is used to move the word or byte from one string to another. And then the LODS and LODSB and the LODSW, it is used to store the string byte into AL or string word into AX. Tapos, OUT-SB or OUT-SW, it is used as an output string or byte or word from the provided memory location to the I/O port. Next. So to give an example, so ito kapag word or byte yung inaano ng string. So yung offset source, tsaka yung destination source, meron silang mga 16-bit pointer. So, sinasabi lang dito na yung offset source, ang 16-bit pointer niya is yung source index. Tapos, yung offset of destination naman, ang 16-bit pointer niya is destination index. Tapos, nakalagay dito na yung 16-bit pointers, they are used to store offset address. So, nakikita nyo lang na yung source, i-move lang papunta sa destination. Next. So, ito naman kapag multiple word or byte yung pinaprocess sa string. So, CLD or the clear direction flag. So, DF, ang ibig sabihin yan is direction flag. So, kapag yung direction flag mo is equal to 0, yung SI and yung DI mo will automatically increment. So, next instruction is the move AX tapos 0000H. So, ibig sabihin yan na yung 000, makakontain yan yung AX. So, ang value na ngayon ng AX mo is 0000. Tapos, next one is move DS, tsaka move ES. So, yung data segment or the DS, siya yung nagkikarry ng source. Tapos naman yung ES or yung extra segment mo, yun yung nagkikarry ng destination. So, parehas AX yon. Tapos, next yan, move SI, 2000H, tapos move DI, 2400H. So, offset address 2000 to 2400, the data will be copied. So, makakopy lang yung values na 2000 papunta sa SI, tapos yung 2400 dun sa DI. And then the next one is the count move, tapos counter or CX, tapos 04H. So, yung 04, ini-indicate niya na yung length ng string natin dito is 4. So, next one is rep or the repeat. So, ibig sabihin, itong process na to, magre-repeat siya until yung counter mo maging 0. Next.
Okay, so next is yung examples sa LODS, LODSB, and LODSW. So, meron tayo ditong byte. Ito yung register na, which is yung AL, 8-bit, and yung word, AX, which is 16-bit. So, i-explain ko ito mamaya kung paano siya mapupunta dyan. So, for example, I have here the instruction CLD, clear direction flag. So, kagaya ng sabi ni Shane, na DF is equals to 0. So, ang SI and DI will automatically increment. So, next, offset S underscore string. So, this is the offset address of the string. Then, LODS S underscore string. So, yung string, meaning accumulator. So, depending if 8-bit siya or byte, sa AL siya. If naman 16-bit siya or word, sa AX siya. So, next.
Program execution transfer instructions. So they are used to transfer or branch the instructions during an execution. Next. Processor control instructions. They are used to control the processor action by setting or resetting the flag values. Next. STC is used to set carry flag CF to 1. CLC is used to clear or reset carry flag CF to 0. STD is used to set the direction flag DF to 1. CLD is used to clear or reset the direction flag to 0. STI is used to set the interrupt enable flag to 1. And the CLI is used to clear the interrupt enable flag to 0. Next.
So, next is iteration control instructions. Are used to execute the given instruction for number of times. So, meron tayo ditong LOOP or loop, used to loop a group of instructions until the condition satisfies or yung count register, kagaya ng sinabi ni Shane kanina, ay magiging 0. Then, LOOP or LOOPZ used to loop a group of instruction till it satisfies the 0 flag na magiging 1 and the count register na magiging 0. So, next.
So the interrupt instructions are used to call the interrupt during program execution. INT or the int is used to interrupt the program during execution and calling service specified. Int O or the int2 is used to interrupt the program during execution if OF is equal to 1. And then IRET is used to return from interrupt service to the main program. Next. So it's the last slide na pala. So that's everything for data movement. Now let's move on to the next reporters, and their topic is data processing.
Hey guys, I'm Francesca Habing and I will be reporting about data processing activities, and data processing cycle. So before we proceed with the data processing, I will be explaining what a data and information are. So data refers to the raw facts that do not have much meaning to the user. So these are the ones that the user inputs, like the numbers, letters, sounds, symbols, and images. So this data undergoes a certain steps or cycle in order to obtain an information. So what is an information? An information refers to the meaningful output obtained after processing the data. So these are the result, or for example, the ones that are being displayed in a monitor. So data processing. Data processing is the manipulation of data by a computer. It includes the conversion of raw data to machine-readable form, flow of data through the CPU and memory to output devices, and formatting or transformation of output. So if ang computer ginagamit siya to perform defined operations sa isang data, it is included under data processing. Data processing also follows a cycle where inputs or raw data undergoes a certain process sa computer system, sa software, or etc. in order to produce an output, which are the information and insights. So, in a way, sa data processing, ginagamit siya to carry out a series of operations on the data para mag-present, interpret, and obtain information. So, data processing activities. Data processing consists of those activities which are necessary to transform data into information. So, data processing can be done manually, mechanically, and electronically. But regardless of this, may certain functions and activities siya na kailangan to be performed for the data processing. And these are grouped under 5 basic categories. So, first is collection. Dito nangyayari yung data gathering, wherein a data is collected from its original form or yung raw data, and then it is being measured and recorded. So, next is the conversion. Conversion is the process of translating data from one format to another. These steps enables the data to be read, altered, and executed in an application or database. So, in a way, sa conversion, itatransform niya yung data collected into machine-readable form para maklasify siya easily ng receiver. So, next is manipulation. Manipulation refers to the process of adjusting data to make it organized and easier to read. The manipulation does this by sorting, calculating, summarizing, and comparing each data. Next is the storage. Storage refers to keeping data in the best suitable format and in the best available medium. So, it also keeps the data for future needs in order for it to be retrieved easily. So, next is communication. So, communication refers to the exchange of data between a source and receiver via the form of transmission media. Data processing cycle. The data processing cycle is a series of steps carried out to extract information from raw data. Although each step must be taken in order, the order is cyclic. So, the data processing cycle, inalaw niya tayo na makita kung paano natatravel yung data and how it is transformed from collection to interpretation. It is often referred to as cycle because the output obtained can be stored after processing and may be used in future as input. So, there are 6 stages of data processing cycle. First is the collection, and then it undergoes into the preparation, input, processing, output, and data storage. So, as you can see, there is an arrow or connection between the data input and the data storage. So, sa data input kasi, dito na nangyayari yung conversion. So sa mga information na na-convert ng data input, may mga datas doon na hindi pa kailangan i-process agad. So, this means na yung data na yun ay mapupunta muna sa data storage in order for it to be stored, and then tsaka siya i-retrieve when needed in the future. Kapag nangyari yon, babalik siya ulit sa data collection cycle hanggang sa makapunta siya sa data output. Collection. Collecting data is the first step in data processing. So, as you can see dito sa picture, data is being pulled from available sources including data lakes and data warehouse. The collection process needs to ensure that the data gathered are both defined and accurate so that the subsequent decisions based on the findings are valid. So, this stage provides both the baseline from which kung alin yung i-measure and kung alin yung mga kailangang i-improve. Next is the preparation. So once the data is collected, it then enters the data preparation stage. The data preparation, often referred to as pre-processing, is the stage at which raw data is cleaned up and organized for the following stage of data processing. So, during preparation, data preparation, as you can see dito sa picture, yung raw data, chine-check siya for errors. So, the purpose of this step is to eliminate bad data like yung mga redundant, incomplete, and incorrect data, and to begin to create high-quality data. Next is data input. So, the clean data is then entered into its destination, perhaps a CRM like Salesforce or a data warehouse like Redshift. And the verified data is coded or converted into machine-readable form so that it can be processed through a computer. So, the data input, ito na yung first stage in which yung raw data it begins to take the form of usable information. Kasi dito na nangyayari yung conversion. So next is processing. During this stage, the data inputted to the computer in the previous stage is actually processed for interpretation. It is when the data is subjected to various means and methods of manipulation, the point where the computer program is being executed and it contains the program code and its current activity. So, actually, sa processing, dito na nangyayari yung gumagamit siya ng machine learning or algorithms. Kaso, nakadepende siya kung ano yung source of data and how it is intended to use. Next is the data output or interpretation. The output interpretation stage is the stage at which data is finally transmitted to the user. The translated readable output is presented to the user in various report formats like printed report, audio, video, or on a monitor. So the output needs to be interpreted so that it can provide a useful information to the user. Lastly is the storage. The final stage of data processing is storage. After all of the data is processed, it is then stored for future use. Plus, the properly stored data is a necessity for compliance with data protection legislation like GDPR. So, ang importance ng cycle na to is to allow quick access and retrieval of the processed information, allowing it to be passed on to the next stage directly when needed. So, that is the end of my report. Thank you.
Hi everyone, my name is Hyacinth Escosura and I'll be presenting the description errors in data processing methods, and lastly is the electronic data processing methods. Okay, so the first one is the description errors in data processing. Under it are computational errors, transcription errors, and algorithm or logical errors. Okay, so the numero uno is the computational errors. It occurs when an arithmetic operation does not produce the expected results, and the most common computation errors include overflow, truncation, and rounding. So the first one is the overflow errors. It occurs if the result from a calculation is too large to be stored in the allocated memory space. For example, if a byte is represented using 8 bits, an overflow will occur if the result of a calculation gives a 9-bit number. Next one is the truncation errors. Result from having real numbers that have a long fractional part that cannot fit in the allocated memory space. So the computer would truncate or cut off the extra characters from the fractional part. For example, a number like 0.784969 can be truncated to 4 digits to become 0.784. The accuracy of the computer output is critical. As the saying goes, garbage in, garbage out, or GIGO. The accuracy of the data entered in the computer directly determines the accuracy of the information given out. Okay, so the next one is the transcription errors. It occurs during data entry. Such errors include misreading and transposition errors. So the misreading errors are brought about by the incorrect reading of the source by the user and hence entering wrong values. For example, a user may misread a handwritten figure such as 589 and type S89 instead, example, confusing 5 for S. Okay, so the next one is the transposition errors. Results from incorrect arrangement of characters, example, putting characters in the wrong order. Okay, for example, the user might enter 396 instead of 369. These errors may be avoided by using modern capture devices such as barcode readers, digital cameras, and etc., which enter data with the minimum user intervention. Okay, so the next one is the rounding errors. Results from raising or lowering a digit in a real number to the required rounded number. For example, to round off 30.666 to one decimal place, we raise the first digit after the decimal point if its successor is more than or equal to 5. In this case, the successor is 6, therefore 30.666 rounded up to one decimal place is 30.7. If the successor is below 5, example 30.635, then we round down the number to 30.6. Okay, so the last one under the description of error is the algorithm or logical errors. An algorithm is a set of procedural steps followed to solve a given problem. Algorithms are used as design tools when writing programs. Wrongly designed programs would result in a program that runs but gives erroneous output. Such errors that result from wrong algorithm design are referred to as algorithm or logical errors. For example, here, you inputted average of 5 scores equals the sum of scores divide to 2, but it should be divided by 5, right? Okay, moving on to the next one, which is the data processing methods. As mentioned earlier, data can be processed manually, mechanically, and electronically. So the first one under the data processing methods is the manual data processing. In manual data processing, most tasks are done manually with a pen and a paper. For example, in a busy office, incoming tasks, which is the input, are stacked in the tray, which is the output. The processing of each task involves a person using the brain in order to respond to queries. The process information from the out tray is then distributed to the people who need it or stored in a file cabinet. Next one is the mechanical data processing. Since manual is cumbersome and boring, especially repetitive tasks, mechanical devices were developed to help in automation of manual tasks. Example of mechanical devices include the typewriter, printing press, and weaving looms. Initially, these devices did not have electronic intelligence. Okay, so the next one is the electronic data processing. For a long time, scientists have researched on how to develop machine or devices that would stimulate some form of human intelligence during data and information processing. This was made possible to some extent with the development of electronic programmable devices such as computers. And the advent of microprocessor technology has greatly enhanced data processing efficiency and capability. Some of the microprocessor controlled devices include computers, mobile phones, calculators, fuel pumps, modern television sets, and washing machines, etc. So, lastly is the electronic data processing methods. There are several ways in which a computer under the influences of an operating system is designed to process data. Number one is the online processing. In online processing data, the job received by the system is processed at the same time of receiving. The computer is connected directly to the data input unit via a communication link. So the data input may be a network, terminal, or online input devices attached to the computer. Okay, next is real-time processing. Computer processes the incoming data as soon as it occurs, updates the transaction file, and gives an immediate response that would affect the events as they happen. This is different from online in that for the latter, an immediate response may not be required. The main purpose of a real-time processing is to provide accurate, up-to-date information, hence better services based on a true real situation. For an example of a real-time processing is making a reservation for airline seats. A customer may request for an airline booking information through a remote terminal, and that requested information will be given out within no time by the reservation system. If a booking is made, the system immediately updates the reservation file to avoid double booking and sends the response back to the customer immediately. Okay. Next one is the distributed data processing. Under it is the multiprogramming. It refers to a type of processing where more than one program are executed apparently at the same time by a single central processing unit. Okay. So this distributed data processing refers to dividing or distributing processing tasks to two or more computers that are located on physically separate sites but connected by data transmission media. For example, a distributed database will have different tables of the same database residing on a separate computers and processed there as need arises. This distribution of processing power increases efficiency and speed of processing. An example is in the banking industry, where customers' accounts are operated on servers in the branches, but all the branch accounts can be administered centrally from the main server as if they resided on it. In this case, we say that the distributed database is transparent to the user because the distribution is hidden from the user's point of view. Okay, so the next is time sharing. In a time sharing processing, many terminals connected to a central computer are given access to the central processing unit apparently at the same time. The single CPU is used by multiple users, and all users share same CPU, but the time allocated to all users might differ. The processing takes place at different intervals for different users as per allocated time. Since multiple users can use this type, it is also referred as multi-access system. This is done by providing a terminal for their link to the main CPU, and the time available is calculated by dividing the CPU time between all the available users as scheduled. So the next one is batch processing. Data is accumulated as a group or batch over a specified period of time. Example, daily, weekly, or monthly. The batch is then processed at once. For example, in payroll processing system, employees' details concerning the number of hours worked, rate of pay, and other details are collected for a period of time, say 1 month. These details are then used to process the payment for the duration worked. Most printing systems use the batch processing to print documents. Okay, so the next one is multiprocessing. Refers to the processing of more than one task at the same time on different processors of the same computer. This is possible in computers such as mainframes and network servers. In such systems, a computer may contain more than one independent central processing unit which works together in a coordinated way. At a given time, the processors may execute instructions from two or more different programs or from different parts of one program simultaneously. This coordination is made possible by a multiprocessing operating system that enables different processors to operate together and share the same memory. The users of the distributed database will be completely unaware of the distribution and will interact with the database as if all of it was in their computer. That's it. Thank you.